Hello everyone and welcome to the extensive lecture series organized by Center for Computational Technologies, CCTech Pune. This lecture is dedicated for geometry creation in pre-processing tool that is ANSYS ICEMCFD. We do hope that everyone is familiar with user interface of ICMCFD as we have already covered this in the previous lectures. Before going ahead with this particular lecture, let us have a review of topics which we have covered in the previous lectures as well as the topics which we intend to learn in this current lecture. What did we learn exactly in the previous lecture? We familiarized ourselves with CFD pre-processing. We saw what exactly is ICMCFD and how does its user interface looks like. We also discussed in detail the entire process flow through ICMCFD. In this particular lecture, what do we intend to learn? We will see ways to import geometry into ICMCFD. We will also see how to create basic entities of geometries like points, curves, surfaces, and bodies, and how to edit them. We will also see how to build topology and how to repair and transform geometry. In our previous lectures, we have already discussed that geometry is the base of the entire CFD process. It is the geometry through which we extract the solution domain within which we model or simulate the physics involved. We further mesh the geometry and export this geometry into the solver. Hence, it is extremely important to know how geometries are created in ICMCFD. There are two ways to do this. One is to import the geometry from a third-party CAD software or design modeler into ICMCFD. The other way is to build the entire geometry in ICMCFD. If we intend to import geometry from a third-party CAD software, there is an option within ICMCFD in the file menu called Import Geometry. Using this option, we can import geometry in file formats like STL, Parasolid, DWG, STEP, etc. Once we have imported a geometry, a pop-up window will open up and it will ask for dimensions in which the geometry was created in the parent software. After this, a .tin file is generated, which is basically a working folder which can be reopened in ICMCFD at any later stage. In the second method, that is, if we intend to build the geometry in ICMCFD itself, this can be done by using various basic entities like points, lines, curves, surfaces, etc. But while doing this, it should be remembered that ICMCFD is not a feature-based software, which means that if we build a 2D rectangular surface from basic entity that is curve or line, we cannot change the dimension of this rectangular surface by changing the dimensions of the line or curve involved. We have to rebuild the rectangular surface using lines and curves. Now let us take a flavor of different options available in ICMCFD for geometry creation. Go to Geometry Functions tab and click on Geometry tab, which will expand to different geometry creation, geometry modification, and geometry fixing options. The following are the options as we proceed from left to right. Create point, create modify curve, create modify surface, create body, create faceted, repair geometry, transform geometry, restore dormant entities, delete point, delete curve, delete surface, delete body, and delete any entity. Let us first focus on the lowest geometry entity of ICMCFD, that is point creation. This is the first option in Geometry tab as highlighted in the figure shown. When you click on the points option, a window will expand which includes the part name and different point creation and modification options. Let us have a gist of these options as we proceed from left to right as follows. We can create points by using screen select, by explicit coordinates, by base point and delta method, by center of 3 points method, by parameter along a vector, by curve ends, by curve intersection, by parameter along a curve, by projecting a point to curve, and projecting a point to surface. Then comes the lower geometry entity of ICMCFD, that is curve creation. This is the second option in the Geometry tab as highlighted in the figure shown. When you click on the curve option, a window will expand which includes the part name and different curve creation and modification options. Let us have a gist of these options as we proceed from left to right as follows. We can create curve from points, by arc through 3 points, by arc from center, by surface parameter, by surface-surface interaction, by projecting curve on surface, by segment curve, concatenate curves, surface boundary. We can also modify curves, that is reverse direction, extend them, match curves or bridge curves, midline curve and section curve. We will discuss all these methods in detail in the coming slides. Finally comes the highest geometry entity of ICMCFD, that is surface creation. This is the third option in the Geometry tab as highlighted in the figure shown. When you click on the Surface option, a window will expand, which includes the part name and the different surface creation and modification options. Let us have a look at these options as we proceed from left to right. We can create surfaces from curves, by curve driven, by sweep surface, by surface of revolution, by loft surface, by offset surface, by mid surface, by curtain surface, by segmenting or trimming another surface, by merging or reapproximating surfaces, by geometry simplification, and creating standard geometry. We will discuss all these options in detail in the coming slides. Before discussing the various geometry creation operations in detail, we will first clear some basic terminologies which will be used repetitively. There is something called part, which is label or the name of the boundary of the entity used in solver. You can either specify new part name or may choose existing part name by selecting it from the drop-down list. If no entity name is given, the name of the point will be the part name with numeric extension. If inherit part is activated, then the entity will have the label of existing part from which it was constructed. The default naming convention is described under settings, which include geometry options. The geometry options allow you to set geometry preference such as default part name, etc. Now we will discuss the point creation operations in detail. The first and the simplest is the screen select option, which is represented by the desktop sign. This is the simplest option in which we create a point by selecting a location by mouse on the screen. Once you select the location, press the middle mouse button to complete the selection, then the point will be generated. Next is specifying the coordinates explicitly. This explicit coordinate option allows you to create a point by specifying its XYZ coordinates, or create multiple points as a function of an equation. This option allows you to create multiple points defined by a function of one variable, say m. The expression can have any mathematical operators such as plus, minus, sine, cosine, etc. There are two possible formats to define the variable m. The first is the list format, in which we specify the values up to last value as a simple list of variables. The second is the values in the loop format, in which we specify the first value, the last value, and the increment delimited by commas. Next is the base point and delta option. It is given by this particular icon. This option allows us to create a point with a reference to an existing point. We have to select the base point and an incremental distance or delta from that point in x, y, or z direction. The increment can be positive or negative. Next is the center of 3 points option, which can be located by this particular icon. This option allows us to create a point with equidistant from 3 points which form an arc. Next is the based on 2 locations option. It is given by this particular icon. This option allows us to create points between locations on any entity or in space. It has 2 options. Either we can create an equally spaced n number of points between 2 selected locations, or we can create a parametric point along 2-point vector by giving a parametric value between 0 and 1. Next is curve ends option. It is given by this particular icon. The curve ends option allows us to select a curve to create points at 2 ends of the curve. We will move to the next option, that is curve intersection, which can be located by this particular icon. This option allows us to create a point at the intersection of 2 curves. For this, we need to select the 2 curves and specify the gap tolerance between the 2 curves. Next option is parameter along the curve option, which can be located by this particular icon. This option allows us to create a parametric point along a curve. Similar to 2 location method, it also has 2 options, which are either specifying the number of points or to specify a parametric value. Next option is project point on curve option, which can be located by this particular icon. This option allows us to create points by projecting existing point to any curve. If we trim curve option is activated, then the resulting curve on which point is projected will split into parts. The last option in point creation operation is project point on surface, which can be located by this particular icon. This option allows us to create points by projecting an existing point or points to surface. For this, we first select the surface and then select the point to be projected. Now we will move to the next higher geometry entity, that is curve creation operation. Starting with first option from point, which can be located by this particular icon. The from point option allows us to create a B-spline curve by interpolating through n number of points. We can create B-spline curve either by selection of existing point or from screen select. Next option is arc from 3 points. It can be located by this particular icon. The arc option allows us to create an arc from 3 points. It is available with two options in drop-down list. The first one is generation of B-spline arc either by selection of 3 points, and the second one is generation of arc from the center and 2 points. In this option, we can specify the radius value of the arc by enabling the radius option. Further, there are two ways the arc can be generated, that is keep center or keep start end. The keep center option will take the first point selected as the center, the second point as the start point of the arc, and calculate the arc end from the vector defined by first point and second point. Next option is circle from center and 2 point. This option allows us to create a circle of specified radius and known plane. In this option, we can specify the radius value by enabling the radius option. If disabled, the radius will be set at a distance between the first 2 points selected. We need to specify the start angle and end angle and the 3 points which define the working plane. Next option is surface parameter, which can be located by this particular icon. This option allows us to create a parametric curve along a surface. It is available with 3 options in the drop-down list. First one is direction on surface. Second one is point on edges, and third one is by parameter. The first one allows to select 2 points to indicate the isoparametric curve used to define the new curve. The second one allows to select a location on the surface to create a curve which passes through the location, and it is always normal to the edge. It will automatically use the nearest edge from the selected location. Thus, curve will be generated on that location. The last option allows us to select either the U or V direction. Also, we have to specify the parameter value between 0 and 1 to create an isoparametric curve on that surface. Next option is surface-surface intersection. It is shown by this particular icon. This option allows us to create an isoparametric curve from two intersecting surfaces. The intersecting curve can be created in 3 different ways. First, by selection of the surface from the screen. If only a different part option is enabled, then curves will be created at the intersection of the selected surfaces from different parts only. If it is disabled, then curves will be created at the intersection of all the selected surfaces. If no surfaces are selected and apply is pressed, then the operation will be applied to all surfaces in the geometry. The second operation is by selection of parts. We can select n number of parts. The selected parts will participate in the operation. And the third one is by choosing 2 sets of selected surfaces. We can choose the option to create either a faceted curve or a B-spline curve. It is observed from the complicated surface that this option works pretty effectively than the first one. Next option is project curve on surface, which is given by this particular icon. By this option, we can project existing single or multiple curve onto surface. This option allows us to trim the surface on which the curve is projected by enabling the trim option. We can either retain or delete the original curve. If we desire to project the curve in specified direction, then it can be done by selecting specified direction in the drop-down list. Next comes the segment curve. It is given by this particular icon. The segment curve option allows us to segment an existing curve into new curves. This operation is done by either a point or by curve or by plane or by connectivity or by angle. Some important points to note are by curve option also allows us to segment both source curve and target curve. For using the plane option, we have to select a plane to segment the curve by selecting an axis normal to the plane and a point on the plane, or a vector normal to the plane and 2 points on the plane. Next operation is concatenate or reapproximate curves, which can be located by this particular icon. This option merges two or more existing curves into one new curve. The concatenate option allows us to join the curves selected that are separated by a gap less than the given tolerance limit. The reapproximate option allows us to redefine the curve based on a locally set triangulation tolerance instead of the global tolerance. Next operation is extract curve from surface, which can be located by this particular icon. This option allows us to extract the boundary curve from a given surface. We can choose the option of either a surface is faceted or B-spline. Here we are going to discuss about B-spline as we mostly deal with B-spline surface. There are two options available with this, that is check topology and create new. If check topology is enabled, new curves will be created only on surfaces that don't have curve attached to them. It means that wherever there is no curve attached to the surface, that will be created to avoid extra curve. While the create new option allows us to create curve for each surface edge. Next option is the modify curve option given by this particular icon. First among them is the reverse direction option, which allows to reverse the direction of the curve such that the start and the end point of the existing curve are changed in order. Next is the extend operation. This option allows us to extend the curve to specified point or curve or extend the curve by desired length. The method of extend to curve allows us to extend curve to another selected curve. This extension results in a straight line tangential with the end of the original curve. This method also allows us to extend the target curve along with the source curve by enabling allow extend target curve option in it. The last method of extend to length extends the curve by specified length. If the curve is a straight line, then it will extend as a straight line. If the curve is an arc, it can be extended as an arc or a straight line. Next in modify curve is the match curve. It can extend curve or curve to match at a point, tangency and or radius of curvature. Different methods are available by which the curve can be matched, such as common endpoint and tangency, common endpoint, tangency and radius of curvature, common endpoint and radius of curvature. The accuracy of matching can be given in terms of either the geom method or exact method. The geom method performs geometric matching with internally set factors. The exact method matches the endpoint, tangency and or radius of curvature as closely as possible. As we can see, the exact method gives better accuracy. Both source and target curves can be modified. Let us look into detail the matching operation. As shown in the example, if we match both curves by common endpoint method, the resulting configuration will be as shown in figure A. Similarly, if we match both curves by common endpoint, tangency and radius of curvature, the resulting configuration will be as shown in figure B. The last operation in extend curve option is bridge curve. This option allows us to create a new curve that connects two existing curves in order maintaining the tangency of first two curves. For this, we have to select the curve along with specifying the curve magnitude. Here, curve magnitude is defined as what distance the tangency of the first curve and the second curve should be kept. Out of the selected curve, first selection is assigned as a first curve and the other as second curve. The curve magnitude implies how far to keep the tangency as a fraction of curve length from start and end point. Curve magnitude ranges from 0 to 1. 0 means no tangency and 1 means maintaining tangency for the 100% of the curve length. Once the curves are selected, we can adjust the curve magnitude by text entry or by moving the slider until the desired shape is achieved. In the figure shown, the first case depicts the first curve magnitude is 0.3 and the second curve magnitude is also 0.3. This means that the resulting bridge curve will have 30% tangency of first curve and 30% tangency of the second curve. Similarly, if we take third case, the first curve magnitude is 0.7 and the second curve magnitude is also 0.7. We will notice that tangency to both curve cannot be maintained for 70% of the curve length, so a compromise is made. If we observe the last case, the first curve magnitude is 1 and 0 for the other. It means that the tangency to the first curve is taken for the full length of the bridge, but it does not maintain the tangency to the second curve. Next is create midline, which is given by this particular icon. This option allows us to create the midline between two curves or a set of curves. The last option in curve creation operation is create section curve. The icon looks as shown. This option allows us to create new curve at intersection of selected surfaces with single or multiple plane. For this, we need to choose plane setup, which implies to specify the plane that intersect with the selected surface to create new curve. This is available with three options: normal to XYZ plane, 3 points and along existing curve. For first one, we have to select plane normal to XY or Z axis. We can also specify the offset value, which is the fraction of distance between start and end point. Plane will pass through each offset point as well as start and end point, resulting in multiple section curve. The other method of plane setup is by choosing 3 points which define a plane. This plane and selected surface result in intersection to curve. Another method is normal to existing curve. You have to select surface, curve, and specify number of section. The number of section means equally distributed plane normal to selected curve are used. Let us now discuss in detail the surface creation and modification operations. Starting with the first option in surface creation, that is from curve, which is given by this particular icon. This option allows us to create surfaces from curve. Under this, different options are available for creating surfaces from curve. The first one is creating surfaces from 2, 4 curve. We have to provide tolerance value such that adjacent curve ends within this tolerance distance. For the complicated geometry, other option known as from curve is suggested. By this, we can select any number of curve to form a surface. They can be overlapping or disconnected. Next is from 4 point. This option automatically closes point using a best fit approximation. Next is curve driven. This option allows us to create a surface by sweeping one or more curve along a guiding curve. The curve to be swept is called as driven curve and the curve which guides it is known as guiding curve. The direction of the driven curve changes with the curvature of the driving curve. Next is sweep surface. This option allows us to sweep the existing surface edge along the guiding curve or the vector. The orientation of the surface edge remains constant along the driving curve. The next one is surface of revolution option, which is given by this particular icon. This option allows us to create a surface by revolving any reference curve around an axis. This axis is defined by specifying the 2 points on screen. It also asks us the start and end angle for the curve to be revolved. The default is from 0 to 360. The next option is loft surface over several curve. This option allows us to create surface across 2 or more curve by interpolating between those curve. We need to specify tolerance value. The next is offset surface. This option allows us to create new surface by offsetting an existing surface. For this, we have to enter the distance at which the new surface is to be offset. Thank you for viewing this particular part of the lecture series. If you have any further questions or for any other information, please contact our email address info@cctech.co.in. Alternatively, you can also visit our website www.cctech.co.in.